All right, now to the most important part of the meeting so far, and that is a demonstration. And for that, I'd like to bring on Phillip and Eduardo.
Thanks, Harry. Hello, everyone. I'm Phillip Tomaszewski, Senior Application Engineer at Tatsoft, and today we will show you two quick demos. In the first one, we will collect field data, publish it to an MQTT broker, and make it available for machine learning. To help me on this, I did bring Eduardo. Hi, Eduardo. How are you doing today?
I'm great, thank you. I'm Eduardo. I'm an automation engineering at Tatsoft. So let's keep this practical and fast. In this first demo, we collect data from devices on the field and publish it to an MQTT broker. With the historian module, we can historize this data into a SQLite database. The script module comes into the scene applying machine learning models to our demo. Finally, we visualize the data in a display using the display module.
All right, but there is just one little challenge that I would like to propose. Do you think we could do that in 10 minutes?
Absolutely. I'm 2 steps ahead of that and already did it.
Cool. So show us what you have.
Okay, so let's start creating a new solution. For this, we are going to use a template called Portable Layout, which allows us to visualize in different devices. The first step is to create the tags. Instead of typing them manually, we asked our GPT-based assistant, the FrameworX assistant, to generate a list of tags for a bottling line. It returns names, descriptions, and suggests data types. So I'll copy that list, and then we are going to the unified namespaces and tags. Paste the rows, and the platform already creates the tags for us. With that, we have the tags we needed. Next, we need values changing in real time. In devices, protocols, I'll add the first protocol, the value simulator. This protocol acts like a field device continuously producing data so we can test the flow. In a real project, this could be any industrial protocol. For the demo, a simulator keeps it simple and fast. We simulated the data ready. Let's publish it via MQTT. I created an MQTT node and pointed it to the broker. Here we are using the Hive MQ. Then in the point list, I paste the same tags and set the access type to write. So these points will be written to the broker. And to keep the things tidy, I'm grouping by node to show now that we have multiple nodes configured. At this point, data from our simulated tag are ready to be published to the MQTT broker. Now let's store the data. In Historian, I select our default Historian configuration. Simply pasting the tags into the Historian tag list is enough for them to start being logged. In this demo, we are using the SQLite for convenience, but you could swap to another database provider in real deployment. So now it's time to add a little intelligence. I create a class by importing it from our code library. It's called anomaly ML. This class encapsulates a machine learning logic that we need. So if you open the script, you see the how to use section that explains everything about this section and how to use it. So we will trigger it using the expression, and every time the tag chosen changes its value, the expression fires, which calls the machine learning method. I'll pick just one tag here for reference, so when it changes, it will trigger. And finally, let's visualize it. I'll create a simple display page to act as our dashboard. To build it quickly, I drag the tags we want onto the canvas, and from there I can drop the gouge and add it to the display.
Eduardo, if you allow me, just a helpful tip. You know that every time after you place a symbol, you can right-click and choose Change Symbol without losing the data mapping. The tag binds stays intact, so you can basically swap visuals without really having to rewrite everything.
That's correct. And with the page ready, I'll start the runtime. you see the simulated values updating, MQTT publishing in the background, historian logging to the SQLite, and the machine learning expression waking up whenever the selected tag changes. And that's it. In just a few minutes, we did everything that was proposed, and we are ready to move on.
Very good. So, recapitulating that. So you just showed me tags being generated by AI and how fast we can use them into multiple places inside FrameworX to speed up the development. Also, you showed me how to create all I need to make my solution ready for MCP clients, and after all, you still created a nice display to show the information in real time.
Yeah, that's it. It's done.
Impressive.
Seems like we still have some time remaining, so why don't we create another demo just to show them? But this time it's going to be a little bit different because we are going to get the data from the broker, bring it locally, and expose this to an MCP server.
I like the idea. Let's take a look at what I have this time. All right?
Let's go.
For the first step that I have here, I want to create the application. All right? We will start just by creating a basic application and using some basic templates here. And once it is created, we navigate to the Data Explorer and initialize the local broker. With that running, our project has a place to consume our data.
But what data?
That's where it comes our simulator. This data is coming from our MQTT data simulator. For today's example, we will map all the data to our simulation. So everything that we have in the simulation will be on our solution. We will use then the tag provider services to make those incoming MQTT values available to the platform. In the asset 3, we will create a new asset called Europe, and under that, we will import the subset of data that we want to use. The next step, we go to the script classes and create a new class. This will be imported from our class library, all right? This class will be responsible to implement the MCP server behavior exposed in our application. Basically, it means that clients will be able to connect into our application that is tailored specifically for this solution. We will add a basic user interface just to show some data in real time. We will import that from our library too. Then we go to the display layout and set the display as the startup display for the project. Now, all we have to do is start our solution and voila, demo's up and running.
That's impressive, but we still have almost a minute, so what are we going to do with that?
What about a coffee? All right, now that you finished both the demos, could you show me them working?
Sure. Now both solutions are running, and we use Cloud AI to query them using the MCP server that we have been executing. Once we have the Cloud AI installed, we can open the developer settings and configure our MCP server tools.
Hold on. Don't you think we should show them how to do that?
Don't worry, in our documentation, that's every step is there. We provide a step-by-step example on how to do this. Don't worry.
Okay.
After that, any conversation can use the FrameworX connector, which has access to your solution, and from there you can ask questions and retrieve information directly from the application.
All right, that's nice. So let's make some questions to retrieve this information from the solution running. What could be our first question?
What is the system monitoring uptime?
That's a good question. Let's see the answer. Seems like it can validate for how long it's running and tell us precisely the uptime information. For the question number 2, I would like to ask it to get the last anomalies from the bottling line. And as expected, it returned us the information asked.
And what if we ask to return the solar panels power output in Barcelona? And it comes up with information and it's there.
Yeah, but based on your answer, let's finish it making AI send a message back to our application. Send a message to the operator. Congratulations then for their good job. As you can see, the message has been saved into HTML format, and it can be automatically read by our tools. And that's it from us, Harry. We are very excited on all the new things that we have preparing for you in this new version. Thanks for helping me out today, Eduardo, and thanking everyone.
You're welcome.
Thanks, guys. That was a great effort on demonstrating the power, the AI readiness, and the speed of development of FrameworX.